To create a canvas game like we see right here, we're going to have to cover quite a few topics. Specifically, we're going to have to learn how to create a player like we see in the middle, how to shoot projectiles, how to randomly generate enemies so that they come and attack you at random times, how to detect collision for whenever a projectile hits an enemy, when an enemy hits you, how to remove particles off the screen, how to actually colorize these things so it looks good, how to shrink the enemies on hit, how to create particle explosions like you see for every enemy that we actually hit, how to keep track of your score each time you hit an enemy, and then we're also going to want to add a game over UI, a restart button, and then when you refresh the page, we need to make sure that we have a way to actually start the game. So to get started, we're only going to use a simple HTML file and then vanilla JavaScript to code this whole thing from scratch. So first thing we need to do is actually create a project. Now when I create a project, I like going inside of my home directory, and then I created a folder specifically for my web canvas project. So I go inside of web, go inside of my canvas folder. It really doesn't matter where you put this. You can put this in your desktop documents, wherever. And inside of here, I'm going to press Command-Shift-N to create a new folder. And this is going to be called canvas-game. So once I have this folder created, I'm going to go ahead and drag it on top of Sublime Text to open it up in project format. And once I'm here, what I want to do is go to File, New File, and then I'm going to hit Command S to save this new file that I just created. And then I want to find the folder that I just created as well. So we know this is inside of Web, Canvas, Canvas game, and I'm going to call this index.html. This is what's going to house our actual Canvas HTML element. So index.html. And then I'm going to do the same thing. Just go to File, New File, Command S to save, and this is going to be called index.js. So this is our JavaScript file. This is where we're going to write the actual code that produces our game. These two files are going to be working in tandem together, which you'll see shortly. So once I've created these two files, if I open this up in Finder again and double click on index.html, this should automatically open up in your browser of choice. Mine is Chrome, so you'll see it right here. So nothing just yet, but you'll see if I go inside of index.html, create some dummy HTML inside of here, save and refresh, you'll see that the HTML shows in the browser. So you know that this is working and that it is reading our code, but really we want to create a canvas game, not just random HTML text. So to create a canvas game, we need a canvas element. This is what we're actually going to draw on, do calculations, and so forth. Now when I save and add this, and then head over here and refresh the page, and I inspect things by right-clicking and clicking Inspect, you'll see that our canvas element is actually there on the screen, but it's not actually showing anything, nor is it the full width and height of the browser. So that's going to be the very first thing we want to do, is make sure that this canvas takes up the full width and height of the browser. So to do this, we're going to head on over into index.js, and we want to select our canvas but put it inside of JavaScript. So to select our canvas, we'll write const canvas is equal to document.query selector. So when I refer to document, it's referring to all of the HTML tags within this elements tab right here. Everything that our website or web page consists of is going to be referring to this document object. And when I type in query selector, we are looking for a specific HTML element. Which one do we want? Well, we want the one called canvas. So if we replace element here with canvas, save, and then to make sure this works, you can always console log your code. We're just going to console log our canvas const. If we save, refresh, head on over to our console, refresh again. Well, nothing happening just yet. We're not actually reading this JavaScript code. And this is an easy fix. If we head to index.html and look inside of our elements tab, which consists of our HTML markup, you'll see that we're not actually pulling in any JavaScript. We need to make sure that we specify what JavaScript file do we want to pull in. And we know that file we want to pull in is index.js, so we'll go ahead and add a script tag. And a script tag always takes a source. What is the source of the code that we want to reference? The source is no other than index.js. And just to be extra specific here, to make sure that we are looking inside of the correct directory, we can add a /. All this means is we want to select the very first index.js inside of our root directory, which is canvas-game. So now when we save and refresh, look in our console, Well, now we are logging out our canvas element, and it looks exactly like what we have right here. So we successfully selected it. But now we want to actually set its width and height, because remember, looking at elements, not the full width and height of the screen. So to set this width and height, all we have to do is say our canvas's width is going to be equal to inner width. And this is just going to set the width. If we save this and refresh, look at our canvas. Now it's taking up pretty much the full width of the screen. A little bit of space on the left. We'll go ahead and fix that shortly. But you'll see it's taking up the full width just by referencing something called inner width. Now, where do we get inner width from? Inner width is a property of a window object. So the window object consists of all the properties that make up your browser, your current visible screen space. And inside of it, we have all these properties that declare things such as its width, its height, anything related to the browser. Now, the cool thing is, when you're using a window property, you don't actually need to include window. It's going to read the property automatically, and it just makes your code a little cleaner. So on save, refresh, you'll see that it works just as expected. Now to set our height, we're going to select our canvas height and set it equal to inner height like so. So now on save and refresh over here, now it takes up the full height of the browser as well. But we still have the issue where we have this weird kind of spacing on the left and top of the canvas. Now, where is this coming from? Well, if we look at our body element, you'll see that it has margin as specified by the orange outlines on the left and top hand side of the screen. And we might be able to see this a little better by full screening this, clicking on our body element, and you'll see by default, we have a margin of 8 pixels added onto the body element. Browsers add this onto your code by default, but we don't want that at all. We never specified we wanted it, so why is it really there? I don't know. But to get rid of that margin, what we can do is go to index.html, add a style tag, like so, and then we want to specify what element do we want to style to our own liking. Well, no other than body. That is going to be our body tag right here. So we want to set its margin equal to 0, and that's going to take away the spacing on the left and top hand side of the screen. Save, refresh, and now when we look at our canvas, well, nothing on the left and top hand side of the screen. A little boring to start, I know, but it's necessary in order to make your game look good and be the full width and height of whatever browser you're using. So we're going to be referring to this checklist a lot to make sure we know exactly what steps to take in order to create that game we just saw. So the very first thing we need to do is actually create a player. Now to create a player on a canvas, our player, looking back at our example, just consists of a simple circle in the middle, and then once one of these enemies hits it, well, game over, our player dies. Sad. So to create a player, just a circle on our canvas, what we need to do is select our canvas context. Our canvas context is basically just our canvas API that allows us to draw on the canvas, do whatever it is we need to actually get artwork onto our canvas element. So to select our context, we're going to create another const, and I usually call this just C instead of context, or CTX, just because I'm going to be referencing this so much, it's just way easier for me to use C rather than use something very specific. It just makes the code really bulky when you use it over and over again. So typically I always say be specific with your naming, but in this case we're going to go a little shorter and just call this C. So const C is going to be equal to canvas.get context, and then we need to specify what kind of context are we getting, 2D or 3D. Well, this is going to be a 2D game, so we're going to specify 2D here. And then when we console log out our context, which is now stored inside of C, refresh, view our console. Now we have that giant API object that specifies everything related to our canvas and will allow us to draw on top of it. So to create a player, typically you would select your context, like C, and then we would type in a arc function, and basically by specifying this arc function we can draw a circle, fill it in, and then it's going to be on the screen. But we know our player needs to interact with the rest of our elements on the screen, so instead of just creating an arc by default, we are going to actually create a class for our player. So to create a class, we're going to type in class, player, capital P to specify it's a class, and then opening and closing curly brackets. Now, what properties does a player have? And we can reference the done game as a way to determine this. We start our game, well, we have a size for our player. we have a color for our player, and it looks like we have a position because it's always centered in the middle. So this is a good way to determine what properties a player has. So in order to create properties and specify them to a specific class, we need to create a constructor. And this constructor is called each time you instantiate a new version of the player class. What that means is each time we create a new player, well, we're going to give a player all these individual properties to differentiate it from other players we might create. So whenever we create a new player, we're going to add new properties onto that new instance of the player. So what properties should a player have? Well, it should have an x coordinate, should have a y coordinate. We also saw that it had a radius involved with it, so we'll add a radius property. And we also saw that our player has a color property associated with it, so we'll add a color property here as well. But we need to specify what these should actually be when we create a player. So when we create a player, we're going to pass through arguments by specifying new player and then little quotations. And what goes inside of those quotations? Well, we need an x, a y, a radius, and a color. So when we create a color, we're going to pass through these 4 arguments and then set the player's properties to the arguments we pass through. So this dot radius will be equal to the radius we pass through, and then this dot color will be equal to the color we pass through as well. So now whenever we create a new instance of player, we can give them different properties, different colors, different sizes, and different locations on our screen. Nevertheless, it's always good to know how to use classes and constructors as needed, especially with Canvas games. So we have this player class, and that means what we can do is go ahead and create the player. So we'll create a const called player and set it equal to a new instance of the player by specifying new player and then our constructor methods. So what are the properties we want to give this player? Well, to start, I'm just going to specify 100, 100. This is going to put it somewhere up here because the coordinate system of Canvas starts from the top down, so 0 going bigger and bigger for the y-axis, and then 0 getting bigger to the right. And then our radius, I want to specify 30 pixels to start. And then our color, I'm just going to start off with blue. So if you save and refresh, well, nothing happening, nothing being drawn, even when I exit out of this. Why is that? Well, let's go ahead and console log out our player. Check our console and refresh. Well, we have a new instance of our player. We see its color is blue, its radius is 30, x and y 100. But the reason it's not being drawn on the screen is because we haven't specified a draw function using our Canvas context within this player class. So we actually need to draw the player on the screen based off of these properties. So to draw the player, what I like doing is adding my own function inside of this player class, and this is called draw. Simple enough. Arbitrarily named, by the way. You can name this whatever you want. But to be specific, I know that when I call this function, I want to draw my player. So to draw a player, to draw a circle on the screen using Canvas's context, what we're going to do is reference our context with C dot and then begin a path to specify we want to start drawing on the screen. Then we want to create an arc. So Canvas doesn't come with a full circle function, but it does come with an arc function. So you can draw an arc anywhere from here to there, stop, or you could just draw a full circle just like we want. So what should our x coordinate be? Well, when we create a player, we specified that we want it to be at 100. And we're passing through 100 and assigning it to this player's x property. As a result, we can use this dot x within draw. So we're going to start drawing the circle at this dot x, and we're going to do the same thing for y. So our y is going to be equal to 100 as well. Now we're passing through 30 as our radius, so 30 goes here, to here, to here. We're assigning it to this dot radius. That means we can use it right here as our third argument. So now we have an arc of 30 pixels wide. And then we have a start angle and an end angle, and this determines how long your arc should be. So our start angle is going to be 0, and to make this easy on you guys, you don't really have to think of this too much. Our ending arc is going to be math pi times 2. This is basically 360 degrees. It just means we want to draw a full circle. And then drawing counterclockwise, this doesn't really matter which way we draw it because we're drawing a full circle. So we can just put in true or false there. Save this, refresh. Nothing yet. Don't worry, we're going to get there. So how do we actually draw this? So to draw this, what we're going to do is write c.fill, opening and closing parentheses, And then we need to tell our player to call this draw function. So this new instance of player that we have also has a draw function associated with it now because we created one. So what we can write is player draw, call the function, save and refresh, and now we see that this is drawn on the screen. But it's not taking the color that we specified as our fourth argument. So in order to specify a color, right before fill, we can write c.fillStyle, and this is going to be equal to this dot color. And to specify this one more time, really drill it in your head, we take blue, go into our constructor, which is going to be color right here, assign it to this dot color, and then we're specifying our fill style is equal to this dot color. So it's kind of like a chain through code in order to allow us to use object-oriented programming. So when we refresh, now it is equal to blue. Now we're off to a good start, but if we look over here, ooh, our player is in the middle of the screen, not up here. So how do we actually get this in the middle of the screen no matter what size or width our browser is? Well, we're going to have to reference our canvas's width and our canvas's height to dynamically determine what X and Y should be. So instead of specifying 100 right here, what I'm going to do is create a constant called X. And this is just for specificity purposes so I know what I'm actually referencing here. This is going to be equal to canvas width divided by 2. So we take our full canvas width from here, divided by 2. Well, we're right in the center, no matter how big or small our canvas is. So we take X, replace our X coordinate with X, save, refresh. Now our player is in the middle. Let's do the same thing for our Y coordinate. So I'm just going to copy that line, put Y right here, and instead of our canvas width, we want to reference our canvas height. So save, refresh, nothing just yet. And that is because we need to use Y and plug it into where 100 is. So we save that, refresh. Now our player is right in the center, so perfect. Let's go ahead and look at our game checklist. Well, we created a player and we put it in the middle. That's going to check off the very first step. So let's check it off. So next we actually need to shoot projectiles from the location of our player. This is probably going to be the trickiest thing in this whole course, at least I believe, but bear with me. So in order to create projectiles, well, we need to think, what kind of properties does a projectile have? It has the same properties as a player, as in it has an X coordinate, a Y coordinate, a radius, and a color, but it's also going to have one more property, and that is a velocity. So whenever you want to create multiple instances of something, like multiple projectiles being shot from the middle of the screen, you always want to create a class because we're going to be creating new instances of that blueprint, new instances of a projectile each time we click on the screen. So what we want to do is create a class called projectile, open and closing curly brackets, add in a constructor. So what properties should a projectile have? Well, it should have an X, a Y, a radius, and color. These are pretty default for creating any kind of circle on the screen. And then we also want to add in a velocity because we know our projectiles are going to be moving. So now, whenever we create a projectile, we need to assign these arguments to one instance's individual properties. So we can say this instance, X, should be equal to the X that we passed through. We're going to do the exact same thing for Y, the exact same thing for radius, and then the exact same thing for color, and then same thing for velocity. So now we have the blueprint for our projectile's properties, but now we need to actually determine what a projectile should look like. So same deal, we're just going to copy this draw function we use for our player, since we know a projectile is going to be a circle that we shoot from the center of the screen, and what do you know, this draw function produces a circle. So we can reuse our code by copying this and pasting it right beneath constructor inside of our projectile class, and now we can create and draw new instances of projectiles. So let's go ahead and do that whenever we click on the screen. So to activate code when we click on the screen, we want to add in what's known as an event listener. So you'll see right here at the very bottom, I'm going to add in window.addEventListener. And the first argument this takes is what event do we want to listen for? Do we want to listen for when a user presses a key on the keyboard or when a user actually clicks on their mouse? So we know we want to listen for a click event. So in here, we're going to add a string, specify we're listening for a click. And then the second argument is going to be a function. So we're going to create a simple arrow function like so. And then inside of this, I'm going to console log out some text just to make sure this works. So now whenever we click on our window, we should activate this code right here. And you can right click, click inspect, head to your console, pull this down a little bit, refresh. And then once you click, you'll see Go being logged in the very bottom of the console here each time I click on the screen. Now remember, whenever you use something attached to window, you don't need window in the first place. The browser will understand what you're doing, so you can go ahead and get rid of that and just call add event listener instead. So save, refresh, click, and now Go is being logged. Now we don't want to log Go, that's quite a boring game. We actually want to go ahead and create a new projectile, then draw it on the screen wherever we click. So that'll be the first thing we do, and then we'll go ahead and add velocity so that our projectiles move from the center wherever we click. So to go ahead and draw a new projectile on click, we are going to, inside of our click event listener, create a new constant called projectile and set it equal to new projectile. That is the blueprint we want to reference. So projectile takes an x and y just like our player, but the x and y coordinate of where our projectile should go should be equivalent to wherever our mouse is on the screen. So how do we get our mouse coordinates? Well, we're going to get it through an event object. Anytime you call a function in response to a click using add event listener, the first argument within this function is going to be an event object. So you'll see if I go ahead and console log out event, save and refresh, click, well, we are logging out a mouse event. And this mouse event gives you properties related to exactly where your mouse was whenever you clicked on the screen. So you'll see my client X and my client Y were somewhere over here, 172 for the X and 258 for the Y. If I click in the top left-hand corner, it's going to be something close to 0 when I open this up. You'll see it's 8 and 6, pretty close to 0. So these are the X and Y coordinates from wherever we clicked on the screen with our mouse. So we know our X coordinate is going to be event.client X. So this is our Y coordinate, refresh, click. Our Y gets bigger as we go to the right. So we can use this as the first argument within our projectile here. And then we want to do the same thing for our Y coordinate. So instead of client X, we're going to put in client Y. And then we have a few more arguments we need to add in. Our projectiles are going to be smaller than our player, so we're not going to add 30 for our radius, but more, something like 5. And then to differentiate that these are projectiles and not our player, our color for this is going to be red, and our velocity is just going to be null for now since we're not making use of it, but we will shortly. So now on save, refresh, click, nothing happening, because remember, each time you create a new projectile on click, you need to make sure that you also call its draw function, or else the canvas code isn't actually going to activate to get it on the screen. So now beneath projectile, if I call projectile dot draw, save and refresh, click. Now wherever I click on the screen, we get a projectile in that specific location. So this is a good start and shows you how to react to click events, but nothing is actually moving. And to get these moving, we need to know a little bit of trigonometry. So how do we get projectiles moving from the center of our screen? Well, let's go ahead and draw it out. So our home base, our player, is going to be right here in the center. And our projectile needs to go from the center outwards to a particular direction. So our projectile is going to go from the center outwards to that edge, and this edge is exactly where our mouse clicked on the screen. Now, in order to get a smooth effect where the projectile actually moves over time to this position, we need to determine the x and y velocity of this particle. This x and y velocity are going to be related to each other in a particular way that pushes it perfectly up until this point, wherever your mouse is from the center of the screen. So in order to determine the x and y velocities, we need to first get the angle. So this angle is the angle produced by this right triangle right here. This is what we need to get right here. Once we determine what this angle is, we can get the exact x and y velocities in perfect ratio format to send our projectile upwards to the right. So we're going to get the angle. Second, we're going to put it in an a tan 2 function. So a tan 2 is what produces the angle right here. If I get the x distance and the y distance and put that inside of a tan 2, like so, well, this is going to go ahead and produce the angle that we need right here. And this is going to be in radians. Once we have this angle in radians, we can get x and y velocities. And we get these velocities by getting the angle we found right here and putting them inside of sine angle, and cosine angle functions. So sine and cosine, these are just functions that produce a ratio. Sine, for instance, produces a ratio of how big is this opposite side right here to the hypotenuse of this right triangle, hypotenuse being the longest side. Cosine produces a ratio of how big is this x distance right here relative to the ratio. And when you use these two in tandem together, well, we can assign our x and y velocities to both sine and cosine, which is going to produce the perfect ratio to start pushing our particle upwards towards this direction. Now, if this doesn't make complete sense right now, let's just go ahead and watch it in action as we begin coding it on the screen, and you'll see exactly what I mean by these ratios starting to push our particle in a particular direction. So first thing first, we don't want our particles actually spawning wherever we click on the screen. We want them to spawn from the very center. So in order to get something in the center, remember, we reference canvas.width divided by 2. This is our projectile's x-coordinate. And then we're going to do the same thing for our y-coordinate, but instead of canvas width, we're going to reference canvas height divided by 2. Save and refresh, and now when we click, everything is spawned in the center. So similar to what we had in the whiteboard, our particle needs to go from the center to wherever we click on the screen. And this is going to be created using an animation loop. So right now, nothing is actually animating. This is all being drawn on the screen, but we don't have any potential to move it in any which direction because we're not actually running any sort of loop. So in order to create an animation loop, right above add event listener, I'm going to add in a function called animate. And this is something I'm going to call over and over again using request animation frame. So when this is called, it calls a function in return. What function do we want to call? Well, no other than animate itself. So when we put animate inside of here, now whenever we initiate animate, this is just going to loop over and over again. So we can test this by console logging out any kind of text, and then we actually need to call animate, which we'll just do at the very end of our file, like so. Save and refresh. And now you'll see just being called over and over and over again. So now we have potential to start moving things across the screen. And to move our projectile from the center, we're going to be adding on an x velocity to its x coordinate and a y velocity to its y coordinate. So let's go back to our projectile class. And I like adding in another function called update. And this is typically where I just update my class's properties so I can separate what my class looks like compared to where I'm actually manipulating its properties on the screen. So inside of update, what do we want to happen? Well, we want to start adding on our velocity onto each individual projectile's x and y coordinates. So for each frame within our animation loop, we're going to set our x coordinate for each projectile. Our x coordinate is going to be equal to the current x coordinate plus the coordinate's velocity, specifically its x velocity. And we're going to do the same thing for our y coordinate. So y coordinate is going to be equal to its current position plus its y velocity. And when we do this, we're going to start seeing things move smoothly across the screen. Only issue is we haven't passed through velocity for our projectile. If we go to where we are creating projectiles on click, you'll see we only specified null. Now instead of null, we're going to create a JavaScript object with two properties, x and y. That way we can have a different x and y velocity to send this thing in the right direction. To start, x is going to be equal to 1, and y is going to be equal to 1. We save, refresh, nothing happening because we added this update function, but we're not actually calling it on the screen. So where we're drawing our projectile, right after it, if we try calling projectile.update, save and refresh, well, still nothing happening. And that is because our update function right here needs to be called inside of our animate loop, because for each frame we are looping through, we're going to be adding on our velocity. So if we take projectile.draw and projectile.update, put it inside of animate, well, things aren't going to work because now our projectile isn't anywhere to be found. If we refresh, we get this error. Projectile is not defined because it's only defined when we click, and even so, since projectile is being set to a const, well, this is what we call scope. Projectile is only going to be accessible within this event listener callback right here. So instead, we'll go ahead and take this out of click for now. We'll leave our event listener there. And right beneath where we are creating and drawing a player, we will create our projectile on the outside. That way we can access it within this animate function. We don't have any scope issues. We refresh, and now our projectile is just being drawn from the center to the bottom right because its velocity is just set to 1 and 1, which is going to push it downwards to the right. So off to a good start, but obviously not what we're looking for when it comes to actually getting something sent in the right direction. So we know we're going to be drawing multiple particles on the screen within our animate loop. And to actually get these rendered on the screen and moving in different directions at the same exact time, we need to create an array, a grouping of projectiles, and then draw them all out at the same time. So I'm going to show you how to do this. To create an array, a grouping of projectiles, we want to create a const simply called projectiles. Set it equal to an array. So this is what's going to contain all of our projectiles, and we're going to loop through them within our animate loop so that we can draw them all out at the same time. This is basically management for multiple instances of the same object. So we'll comment out this for now, use it later, and we'll also delete this code right here. But when we're inside of animate, for each projectile within our projectiles array, for each projectile within this array, we want to call that projectiles update function, like so. Now we also want to draw that projectiles draw function so we actually get it rendered on the screen, but a simple way to combine these two functions together is just with an update call this.draw. So now we're calling this code right here, and then we are updating the projectile's individual properties. So on save and refresh, nothing yet, and that is simply because our projectiles array doesn't actually have any projectiles inside of it. But if we go ahead, uncomment this out right above our projectiles array, and then put a projectile within this array, we should see it being drawn on the screen. And there we go. So the cool thing is now we can create multiple projectiles and have them all drawn with different properties. So I want to create another projectile going in the opposite direction with a color of green. I just create a new projectile called projectile2, put it within this array, save, and now we have two different projectiles. So you'll see this projectiles array is just a way for us to create multiple particles on the screen and have them all move independently of one another. Now these projectiles are going to be generated, not statically like we're doing right here. We want to make sure that this array is empty to start, but whenever we click, that is when we're going to generate a new particle. So whenever we click, we want to take our projectiles array and then push in a new instance of a projectile. So we know the center of our screen is going to be canvas width divided by 2 and canvas height divided by 2. Our radius was going to be equal to 5. Our color was red. And then our velocity, which is just an object with an x and a y property, is going to be set right here. So each time we click on the screen, we're pushing in a new projectile into that array, and that is going to draw on the screen whenever we click. So save, refresh, and click, and now our projectile is on the screen because we clicked, but only because we clicked. But every time I click, it's still going in the same direction because our x and y velocities are equal to 1. We need to set these velocities using that whiteboard math that I just showed you. So very first thing we need to do is get the angle created from the center of our screen to wherever our mouse is. So the right triangle from here to here to here to here. And this is if I were to click in the top right hand corner. So to get this angle, we're going to be using atan2, which produces the angle based on the x and y distance of your mouse from a particular coordinate. So what we're going to do is create a constant called angle and set this equal to math.atan2. Now, funny thing about this function is it takes y for the first argument, x for the second, y, I'm not completely sure, but that's just the way it works. So we need the distance between our mouse and the center of our screen. So for our y coordinate, we're going to take our destination, which is event, wherever our mouse is clicking, our event.client y minus canvas width divided by 2. And that is going to give us the distance from the center to our mouse. But now we want to do the same thing for our x coordinate. So we want to select wherever our destination is, which is going to be event.client x, where our mouse is on the x coordinate of the canvas, and subtract from it canvas.width divided by 2. And looking back at this, the first argument should actually be canvas height divided by 2. I forgot that this is the y coordinate, and this is the x at the bottom. So if we save, console log out angle, and I'll go ahead and make this a little bigger just to view this easier. Console log out angle and refresh over here. whenever I click, we're going to get the angle produced from where my mouse is to the center of the screen. So if I start clicking closer, closer, closer in this unit circle kind of manner, eventually I'm going to start going negative. But no matter where I click, I'm still getting the exact angle produced by the right triangle from the center to my mouse. And this is produced in radians. So if you're a little confused with me talking about angles and you see these small numbers on the screen, basically 0 to 360 degrees is equivalent to 0 to 6.28 radians. So when I start going around, eventually we're going to hit pi radians, 3.14 over here somewhere. And if I keep going, well, we're in the negative values, which is fine because the coordinate system is a little different here on Canvas, but you can think of it as going to 6.28 as you keep going. So now that we have our angle, all we need to do is set our velocity, which is done using math sine and math cosine. So I'm actually going to create a constant called velocity right here. This is going to be equal to an empty object with an x property and a y property. Now to get our x velocity, we need to reference math.cosine because cosine is always for the x adjacent axis. And inside of here, all we need to do is put in the angle. And this is going to return any number -1 to 1. But now for y, we need to do math.sine, put angle in here, and same thing. This is also going to return any number -1 to 1, but cosine and sine together are going to produce two different results that have a perfect ratio to start pushing your projectile to wherever you clicked on the screen. So now if we take our velocity right here and replace the static velocity that we have as our last argument whenever we create a new projectile, save and refresh, click, you'll see projectile start to move in exactly the position that we click on the screen. Now this is obviously looking pretty crazy with everything being drawn on top of itself over and over again. So we need to make sure that we are clearing our canvas. Basically, we're just going to draw one big white rectangle on top of everything. And when we do this, we're not going to get this effect of lines being drawn out. We're actually going to see each of our individual particles being drawn as circles as they move across the screen. So for each iteration of our animate loop, we will reference our context and call a function called clearRect, which takes an x coordinate. We're going to specify that 0, draw at the top left-hand side of the screen. And if we do that, we want to make sure our y is 0 as well. We want to specify how much of the canvas should we actually clear. We want to clear the whole thing, so we'll reference canvas.width, and then our canvas height. So now on refresh and click, well, our player is gone, but we're actually spawning our particles whenever we click, which is great. But to make sure that our player is always there, well, we need to make sure that we're drawing our player within our animation loop. Otherwise, we're only drawing our player once whenever our file loads, and then we're just clearing over it because we're calling c.clearRect over and over again. So instead of drawing your player right after you create it outside of this animate function, right after we call clearRect, we're going to call player draw. We save and refresh, and now our player is back on the screen. We can click and we shoot projectiles as expected. So looking at our checklist, we now shot projectiles off the screen. Cool stuff, but next step is looking at our canvas piece. Whoo, we need to create enemies, not that many. I don't know why that happened, but we need to create the enemies to start making this an actual fun, playable game. So to start creating enemies, same deal. Anytime you have multiple instances of something, you want to create a new class. So an enemy is going to have pretty much all the properties that we have here for a projectile. So to make our lives easier, what we can do is copy our projectile class and right beneath it, create a new class called enemy. Save, and now we have the ability to create enemies on the screen. The deal is we need to create enemies that go somewhere from the outside of the screen towards the center. But let's go ahead and start spawning these enemies randomly before we get to that point. So to spawn these enemies randomly, what I'm going to do is create a new function called spawn enemies. Simple enough. And inside of this, I'm going to call not request animation frame because request animation frame will call itself as quickly as possible. Instead, I want to call set interval. So the first argument for set interval is the callback function, the code that you actually want to call for each specific interval you specify. So we're going to add in an arrow function and console log out, go, and then the second argument here for set interval is time you actually want to go by between iterations of this call. So I want about 1 second to go by for each iteration, which is going to be 1,000 milliseconds. When I save and then actually call spawn enemies, so copy this name right here paste it beneath animate, save, and refresh. Open up your console. Well, just about every second, we're now calling go. So within set interval right here, we can begin spawning enemies, putting them on random locations on the screen, and then they're going to start moving inwards towards our actual player. So whenever we have multiple enemies, we need to create something that groups multiple enemies together, then draw them all out at the same time. So same deal as we're doing with projectiles. We don't want a projectiles array, but rather we want to create an enemies array. So this is going to contain each instance of each enemy we create. So whenever we spawn a new enemy, we can take this enemies array and push in a new instance of our enemy class. Now enemy takes x, y, radius, color, and velocity. So we can create a constant called x and set it equal to 100 to start. Do the same thing for y. Our radius is going to be equal to, let's just say 30 to start, big enemies, big boys. And then our color is going to be equal to green, just so we can differentiate everything on the screen right now. And then finally our velocity. Let's go ahead and make our velocity equal to an object with an x and y property. This is just going to be equal to 1 for each to start. Now for every second, we can push in these coordinates, this radius, color, and velocity. And if we console log this out for every iteration, our enemies array that is, save and refresh, you're going to see that our enemies array gets bigger and bigger. And this is just what we can loop through so that for each enemy inside of here, we can call this update function, which draws it on the screen and begins moving each enemy individually from one another. So now that we're pushing these into our array, we need to make sure they're actually being drawn on the screen and call that update function. So within animate, we call enemies. For each enemy within this enemies array, call that enemies update function, which calls draw, which then actually updates the individual enemy's properties. So now on save and refresh, we should start seeing enemies being spawned, which there they are, all from the same location, all going in the same velocity. Let's go ahead and start with getting these going towards the center of our player before we do anything else. So same deal, in order to get something moving in the direction you want it to move in, you need to use math atan2, math sine, and math cosine. So we need to get the angle between 2 points. What are the 2 points we need the angle from? Well, where we're spawning each individual enemy and the player on the screen. So we need to get the correct velocity for our enemy that we're pushing in to our enemies array. Let's go ahead and copy this code that we're using to set the velocity for our projectiles. So grab the angle and velocity. And then right beneath this static velocity, we'll go ahead and paste these in. Delete the static one. And now all we have to do is change two properties. So instead of referencing the mouse Y, what we want to do is reference the Y of where our particle is being spawned. So we're declaring Y right here to be set to 100. We say the distance between Y and our canvas height, which is where our player is, and then the distance between X and canvas width, which is where our player is our angle produced, while our velocity should be set perfectly to start moving this actually towards our player. So on save and refresh, you'll see that things are going in the wrong direction. So this is a good thing to note. When you're getting the distance between 2 points, you always want to subtract from your destination. So our destination is actually canvas height divided by 2 and canvas width divided by 2, not y and not x. This is the source. Our destination is going to be canvas height divided by 2. So what we'll do is put that first and then subtract y. We want to do the same thing for our x distance. So what we'll do is take canvas width divided by 2 and make sure that this is positive canvas width divided by 2. Subtract x. Now save and refresh. Now our enemies are moving in the right direction. So what we can start doing is spawning these enemies in random points. If I go ahead and specify the x-coordinate for our enemy should be spawned anywhere from the left to right hand side of our canvas, I'll just go ahead and call math.random, which returns any value 0 to 1, multiply it by canvas.width, save and refresh. Now our enemies are going to be spawned in random locations across the x-coordinate. Y is always going to be the same though, because it's at 100, static number. We want to do the same thing for our canvas height and specify that's where the enemy's Y should be. So save and refresh, and now these are going to be generated in random locations across our whole canvas. But the issue with doing this is sometimes the enemies will spawn really close to our player, and if they touch our player, well, that's when we're going to end the game altogether. So instead of spawning these on the actual canvas, we want to spawn them on the outsides of our canvas. That way we don't get a quick end game by unlucky chance. So let's go ahead and start spawning things randomly on the left-hand side of our screen. Well, let's think of it. What coordinate do we need for one of these enemies to be off the screen to the left? Well, X should probably be 0, and then we have to take into account the radius of our enemies, which is about 30 right now, so we have to subtract that to get it fully off the screen. So X is going to be equal to 0 minus our enemy's radius. Now radius is declared down here, but since we want to use it within X, we need to make sure we take this line that has radius and put it above our X value. So if we save this, now all of our enemies should spawn on just the left-hand side of the screen. So that's looking good, but what if we want the enemies to spawn on the right-hand side as well? Well, X should be either one of two values. It should be negative radius, or it should be our canvas width plus the radius of the enemy. So we need a way to get one of two values randomly. And we're going to do this using a ternary operator. This might be new to you, but basically it's where we use this little question mark within our code. Cool stuff. So basically this is how this is going to happen. I'm going to remove 0 minus radius to start. We need some sort of condition to set this X value to one of two. So the condition we're going to use is math.random is less than 0.5. So if the value for math.random, which math.random produces any value 0 to 1, if it produces any value less than 0.5, then we are going to assign this first value to X. This first value is going to be 0 minus our radius. So if it's less than 0.5, we're assigning this first value. But if it's greater than 0.5, so 50-50 chance, we'll add a colon and call this second value. What is the second value we want to use? Well, canvas width plus our radius, so that it's on the right hand of the screen to start. So we add in canvas width plus our radius, save and refresh. Now our enemies are spawned on random sides of the screen. So this is looking good, it's starting to become more game-like, but we need to do the top and bottom as well. So same deal with the ternary operator. We're going to go ahead and select this code, just go ahead and copy it, assign it to Y. So each time math.random is less than 0.5, what do we want to do? Well, our Y coordinate should be 0 minus the radius. 0 is up here, minus radius, it's going to put it off the screen. This one is good to go, but what should it be if math.random returns a value 0.5 to 1? Well, it should be off the screen on the bottom. So instead of referencing canvas width, we'll go ahead and reference canvas height plus our radius. Now on save and refresh, watch what happens. You'll see everything is just spawned from the corners of the screen. Basically, we create a condition where X can only be 0 or canvas width plus radius, and same thing for Y. It can only be 0 or canvas height. So we need to do this a little differently. Basically, X, if it is spawned on the left-hand side of the screen, Y should be anywhere from 0 to the full canvas height. If it's spawned on the right-hand side of the screen, Y should be anywhere from 0 to canvas height. But if it is spawned on the top of the screen, well, of course, Y should be 0, but X should be anywhere from 0 to our canvas's width. So here's what we're going to do. We're going to create an if statement that calls math.random. It says only activate this next line of code if it is less than 0.5. So the code we're going to call is going to be this to start. Now, since X and Y are inside of an if statement and they're declared as constants, we can't actually use these outside of the if statement. So what we need to do is declare X as a let instead. Same thing for Y. And this way we can reference X and Y outside of the if, and we can also change it later on like we're doing right here. So I'm going to comment out Y, copy it and paste it, uncomment the first one, and then I'm going to set this equal to 0 to start. So let's see what's happening here. So 50-50 chance, we're going to call this if statement that says spawn our enemy either on the left or right hand side of the screen. When this happens, well, our Y coordinate should be equal to any value from 0 to our canvas's height. So we'll just go ahead and multiply math.random by canvas height, and now on refresh, you're going to see that things are spawning in a more random manner from the left and right hand sides of the screen. But we need to do the same thing if the other 50% is called. So 50-50 chance. First 50% we're going to call these lines of code, but the second 50-50 chance we're going to call these lines of code. So in this case, Y should either be 0 or canvas height plus our radius. And we commented out that code right here. We know this is correct. We want to keep that. But when this happens, x should be anywhere from 0 to our canvas's width. So we'll take math.random, multiply it by canvas width. We can delete this commented out code, save, refresh. And now our enemies are going to spawn from all different sides of the screen. Now I want my enemies to be of different sizes. Kind of boring when they're all the same size. Let's go ahead and randomize this a bit. So right now we're just declaring radius should be 30. But let's say I want this from any value 0 to 30 instead. Well, an easy way to do this is just multiply this by math.random. And now radius is going to be set to any value 0 to 30. But the issue with this is even though this is looking good, eventually we're going to get a random value that's less than something like 4. You can see this really small guy right there, and that is going to be very, very hard to hit. Not too fun of a game when things are that hard. So instead of saying any value from 0 to 30, it's more safe to do any value something like 4 to 30 instead. Now here's how you do it with math.random. If you take your max, which is going to be this number right here, wrap it in parentheses, and subtract from it your minimum, which I want my minimum to be a minimum of 4, and then add on your minimum to this whole thing right here. This will make sure that you get any value from 4 to 30. So if I go ahead and refresh with that, we should no longer get any small particles, at least too small to where they're going to be very, very hard to hit, like almost minuscule. And this looks like we are good to go. These all look about 4. No smaller than that. I haven't seen anything just yet. So if you want to set a range, this is going to be your maximum, and these two are going to be your minimum. So that is going to take care of creating enemies on our checklist. The very next thing we need to do is to detect collision whenever an enemy hits one of our projectiles. Whenever this happens, we're going to remove both the projectile and the enemy off the screen to start, so that way we can start fending things off as we play our game. So to start removing enemies whenever a projectile hits, we want to go inside of our animate loop, because for each frame we need to check whether or not one of our projectiles is touching an enemy. So we're looping through all of our enemies already, but for each enemy on the screen, we'll want to loop through each projectile on the screen. This way for each enemy, we can test the distance between every single projectile that we have. So we're going to have a loop within a loop. So we have our enemies loop, and for each enemy within this loop, we want to test the distance between each of our projectiles. So we're going to select our projectiles array, which contains all of our projectile objects, and say for each projectile within this array, select that one individual projectile object, and here's where we're going to start testing the distance between our projectile and our enemies. So what we can do is use math.hypot. And hypot just stands for hypotenuse, and that's just fancy speak for the distance between 2 points. So the arguments for math.hypot are going to be the x and y distance. So what is the x distance between our projectile and enemy? Well, we can get this by taking our projectile's x and subtracting from it our enemy's x coordinate. And then we'll do the same thing for our y. So we select our projectile's y, subtract from it our enemy's y, and we're going to assign this to a constant called dist, short for distance. Now, if you're a little confused, let's go ahead and look in the inner workings of how this actually works. So what I'm going to do is make sure that spawn enemies only calls itself once. And to do that, I can go ahead and comment out set interval, but I still want the code inside of it. So I'm just going to comment out the edges, save and refresh. We only have one enemy, and I'm just doing that so we can view our logs easier within our animate loop, because otherwise everything is just going to get all jumbled up. If I go ahead and console log out our distance and refresh, and then click so our projectile is on the screen, you'll see the distance in between the 2 points. I'll go ahead and refresh again. Once I shoot, it gets smaller, smaller, smaller till it basically touches, gets near 0, and then they start passing so the distance is larger and larger. So when we use math.hypot, set it to our dist, we are just getting the distance between 2 points. Now, we can't actually hit 0. We can't actually tell that the distance between these 2 points is 0, because when we're calculating the distance right now, we're not taking into account the enemies and projectiles radii. Right now, we're just taking the distance between the center of the two, but when they touch, it's the radii that touch, not the center. So what we can say is if the distance between our projectile and the actual enemy is less than 1, then we're going to remove it from the screen. But we need to remember that both our projectile and our enemy have radii associated with them. So it's not just the distance that we need to check is less than 1. We also need to subtract our enemy's radius that we're looping through, and also subtract our projectile's radius that we're looping through. So if this is less than 1, then we want to remove it from the screen, but we're just going to go ahead and console log out, remove from screen to start, save and refresh. So now when I shoot, no console log, but once it touches, for the small amount of time it touched, we get 20 removed from screens. Let's watch it again. Touches, and we call the code. So now we know that they have actually collided. This is what we call collision detection. So now that we know they've collided, we can go ahead and remove it from the screen. And to remove them from the screen, we want to pop the enemy out from our enemy's array and pop out the projectile from our projectile's array. So to remove something from an array, what we want to do is select the array, which is going to be enemies, and use splice. So where do we want to remove the enemy from? What index? Well, to get the index of the enemy we're looping through, the enemy we touched, we can go ahead and use for each's automatic indexing by adding on a second argument, and we're just going to name this index. So this is the index that we're looping through, and we know if we get this far within our code, when things touch, objects touch, that we can go ahead and remove this enemy from our enemy's array. So we'll splice out the enemy at this index, and we only want to remove one enemy from this specific point, so we'll add in a 1. We want to do the same thing for the projectile we're looping through. So we'll take our projectiles array, splice out not the index of our enemy, we need to create a new index, so projectile index, which we can use because we're looping through it using for each. We'll take this and say we want to remove a projectile at this specific index. So now on save and refresh, we go ahead and shoot, and it should be removed. And there you go. Both are removed from the game altogether. They're no longer animating, and we have good performant code. So let's go ahead and create all of our enemies again. Uncomment out set interval so that they are called over time automatically. Save and refresh. Now when I shoot, we can remove all the enemies on the screen. But you're going to notice something happening, and that is the enemies start flashing whenever I actually hit them. Now, why is this happening? Well, I'm removing an enemy from the array, and when I go to the next frame in the animation, it's still trying to draw, even though it's been removed. So it creates that flash effect. To get rid of this flash, where we're removing our enemy and projectile, we can call set timeout, which takes a callback function for the first argument, and then a time for the second argument. This is very similar to set interval, by the way. I'm going to set time equal to 0, but I'm going to place our code right here inside of set timeout. And when I do this, save and refresh, start shooting enemies, we don't have that flash anymore. So basically, this waits till the very next frame to start removing the actual enemy from the array, and that way we don't get that flash effect that we saw. This is just a cool trick to make sure that that flashing is gone. So now, looking at our list, we just detected collision when our enemies and projectiles hit. Now we need to do the same thing for when an enemy hits our player. When an enemy hits our player, we are just going to end the game altogether. Pause the whole thing, and then eventually we'll add an end game screen with our score. So we're already looping through our enemies and checking for the distance between each projectile and the enemy. Now, all we have to do is check for the distance between each enemy and our actual player. So we don't need to add an extra loop or anything because we only have one player. There's not a player's array, so we don't need to create an extra loop like we did for projectiles. So to check for the distance between each enemy and our actual player in the center, we're going to go ahead and take this dist code right here, which gets the distance between 2 points, and right beneath enemy.update, I can paste this, and I can use dist in 2 spots because I'm declaring a constant, and this constant is inside of another callback function, meaning that they have different scope, so I can use this in 2 spots. But the scope I want to use, dist right here, is not going to be the distance between a projectile and enemy, but rather our player and the enemy. So if I go ahead and replace projectile.y and projectile.x with player x and player y, now I'm going to get the distance between each enemy and the actual player on the screen. So same deal, I can use this if statement, paste it beneath dist, and say if the distance between an enemy and our player minus the enemy's radius minus the player radius, not the projectile radius, if the distance is less than 1, then we want to end the game. End game. So now if I console log this out, let's go ahead and type end game here for whenever an enemy hits us, and I refresh. Let's go ahead and watch what happens when an enemy actually touches us. So as soon as it touches, end game is called. So how do we actually end the game? Well, to start, we just want to pause everything on the screen. And everything running on the screen is currently being called by request animation frame. So we can go ahead and actually cancel our animation frame by doing this. We're going to create a let called animation ID, and this is just going to be equal to undefined to start. But whenever we call request animation frame, we're going to set animation ID equal to the result of this. So this by default returns a value of what frame you're currently on. And if you call cancel animation frame and put in the frame that you're on currently, it's just going to stop the game altogether. So we have our animation ID being set, but now when we end the game, we don't want to console log anything. We want to go ahead and call cancel animation frame with the argument of our animation ID. Where should we cancel our game? On this specific frame. So if we save and refresh, now when an enemy touches us, everything should stop. We'll go ahead and see if it happens. And it does. So now our game is essentially over. So we just detected collision between an enemy and our player. We go to our to-dos. We can go ahead and check this one off as well. So the next step isn't the most exciting step, but it's something that needs to happen to make sure our game is performant over time. So you'll see when we play our game, refresh, start shooting projectiles. Well, we can shoot as many projectiles as we want, but eventually they're going to start going off the screen. And even though they go off the screen, we're still going to be animating them. We need to make sure that once they go off the screen, while they're no longer in our game, they are removed from our array and we don't actually perform any computation on them at all. So basically we're performing collision detection, but more so when our projectile collides with the very edges of our screen. So to make sure we're removing our projectiles, within our projectiles loop right here, for each projectile we're going to add an if statement that says if the projectile's x coordinate minus the projectile radius, so that means the projectile is off the screen completely to the left, is less than 0, then what do we want to do? We want to remove it from the screen, remove it from the game altogether. So to remove something, remember, we call these splice functions down here with set timeout. So we can copy this code, paste it within this if statement right here, and we're not looping through any enemies, so make sure you delete this line. But we are looping through our projectile, so we want to splice out a projectile at a specific index. What index do we want? Well, we need to make sure we specify we want to use an index within for each. So whatever projectile is off the left-hand side of the screen, we're going to grab that index and splice it out of our projectiles array at that specific location. So if we save, and then I'm not going to refresh this yet because to test this, I actually want to see how many projectiles are inside of our array as we play the game. So whenever I click, I'm going to console log out, projectiles, save and refresh, start clicking. You'll see our projectiles begin to fill up. We're about 7, 8. And as they reach the left-hand side of the screen, well, it's kind of hard to tell there, but we got up to 7 and 8. And then the ones that went off the left-hand side of the screen, we removed them from our array. So we got down to 6 and 5 particles. Let's go ahead and shoot everything to the left. I'll fend off things as they come, just to make sure we keep going. So we have about 10 particles. And now you'll see we're back at 0 because we removed all the particles off the left-hand side of the screen. No more computations. We have a good, fast game going on. So we'll go ahead and remove this console log. But where we are removing our projectiles, and we'll comment this out just so we know what we're doing. So remove from edges of screen. Where this is happening, we want to make sure that we're removing projectiles also from the right-hand side of the screen. So we can say remove them if they're off the left-hand side of the screen, or remove them if they're off the right-hand side of the screen. So we'll select projectile.x minus our radius is greater than our canvas width. Then we're going to remove things off the right-hand side of the screen. And looking at this, our first statement, this should actually be projectile x plus radius. If that is less than 0, then we want to remove it. But that's going to remove things off the right-hand side of the screen. We want to do the same thing for the top and bottom. So we'll add another OR operator right here and say if our projectiles y plus our radius is less than 0, then we're going to remove it. And then same thing for if our projectile's y minus its radius is greater than our canvas height. So if our projectile plus the size of its radius keeps going downwards and it's greater than canvas height, well, we're going to remove it off the screen. So now we should have full removal for all of our projectiles. So I click and we actually have a bug. Let's go ahead and fix this. Radius is not defined. So right now I'm trying to reference a radius value without referencing my projectile's radius. So I'll just go ahead and prepend this on to each radius like so. Now on refresh, I can click. And we can't really tell if this is working unless we console log things out. So back where we have our add event listener, I'm going to go ahead and console log out our projectiles array. Go ahead and click. You'll see it getting bigger and bigger. You'll see eventually the array goes down to 0 no matter which direction I shoot in. So we know that is working. Perfect. So next up, we're going to start colorizing this so it starts looking like a good, fun game to play. So first thing I like to do is coloring in my background instead of leaving it just white like this. To color in our background, instead of calling clear rect by default goes ahead and clears the whole thing, making the whole background white. We are going to call fill rect so we can basically clear our canvas but using a specific color. So if I call this and save and refresh, well, our background is different colors because we're setting the fill style of different things at different times. But before we fill our rect, we can add in c.fillStyle for each frame we're looping through, and say that we want it to be equal to any other value. So if we specify black right here, well, now we have a pure black background and none of our colors overtake that background color. But I want to specify that this background should be RGBA instead. And I'm going to use 0, 0, 0 for the RGB coordinates, which means it's going to be black. But for our last coordinate, our last value at least, alpha is going to be equal to 0.1. And this changes the opacity of the fill style behind the scenes. Basically, if I do things like this, save and refresh, you're going to see that our particles begin to have fade effects associated with them. Basically, as our particles move, we're only drawing on the background at a certain transparency at a time, which means we get this subtle fade effect as things begin moving across the screen. Kind of looks like light trails. So just a quick way to make your game really stand out and start looking a lot more professional. Now, if we look at the example here, our player is white, our projectiles are white, and all of our enemies are different colors. So I'm going to go ahead and start easy. How do I make our player white instead of blue? And I'm also going to shrink it a little bit to give us a little more breathing room for when we play the game. Well, I would go ahead and find where we are actually creating our player, which I can do by pressing Command F and searching for New Player. This is where we create our player. Instead of having a blue background for our player, I want this to be white instead. So I save and refresh. Now we have a white player, and now instead of 30 for our radius, I want this to be a little smaller. So I'll go ahead and say our radius should be 10. Looks a lot better. And now I want our projectiles to be white as well to match the player. So same deal. If I go ahead and type Command F, type in New Projectile instead of Player, here is where we're creating each individual projectile, which is where we click. Instead of creating each projectile as red, I'll make these white. Save, refresh. Now we have white projectiles. And really quickly, these are just really slow projectiles. Not too fun for me. I don't like it. I like fast things. So instead of using really slow projectiles, what we can do is multiply our velocity by some sort of factor. So if I multiply our velocity by, let's say, 4, it's going to be 4 times as fast. You want to make sure you do this for both X and Y to make sure that this still travels in the direction you click. So once I click, you'll see that those are a lot more responsive, and I might go even a little quicker, maybe 6, refresh, and maybe a little slower actually, because now I'm starting to see the outlines of our individual circles as they travel across the screen. I'll go ahead and stay at 5. So I save and refresh, and that looks really good to me. Now, how do we randomize the colors of our enemies as they start to spawn on the screen? Well, if we look for where we are creating a new enemy, Command F, New Enemy. Here is where we're specifying our enemy's color. Right now they are all green. We want to randomize this. So what I like doing to randomize colors is instead of referencing just a static value like green, I like using HSL, which stands for hue, saturation, lightness. Hue is basically what color are we using? What hue is it? Is it red, green, orange, blue, whatever? This is a value anywhere from 0 to 360, so I'm going to start with 0. Saturation is how deep is this color. I'm going to start with a mid value of 50%, that is. And then our lightness is also a percentage of how bright or dull this color is. So if I go ahead and do 0, 50%, 50%, and make sure that this is exactly the string you see right here, and then refresh, you're going to see our enemies are this pinkish salmon red color. Now this is a good start. We changed the color, but they're not random. To randomize the color of each individual enemy coming at us, we want to make sure this value for hue is any value 0 to 360, because that is the range in which we can put in a value for HSL, specifically hue. So instead of referencing 0 here, I want to use math.random and multiply it by 360, the full range of what hue can take. Now if I save things as is and then refresh, you're going to see all of our enemies are white. And that is because we're trying to call this computation right here, but we're putting it inside of a string. So when we're actually assigning a color to our enemy, it doesn't understand what's going on here because it's actually using the word math.random times 360. We need to make sure that this right here is actually computed. So to compute it, instead of using a string, we can use backticks. And then right before math, we'll use a $, opening curly bracket. And then right after 360, a closing curly bracket, and you'll see this lights up, which means it's going to be computed before it's actually put in the string. This is what we call a template literal, and it's just a really handy way to input computations within your strings. So if we save this and refresh, now all of our enemies are different colors. So we are pretty far along, and I think that this is going to be it for colorizing the game. Okay, so the next step is we want to shrink our enemies on hit. So if we look at our example, you're going to notice when I start hitting these large ones, they start to shrink very smoothly whenever I hit them on the screen. We want to do the same effect for when we hit particles over here. Right now, we're just removing from the screen, but these large guys should really shrink to start adding in more interest and more effect into our game. And later, we can actually make these big ones, as they shrink, have a different point value than actually removing them from the screen. So to get these big guys to start shrinking, we're going to want to find where our projectile actually hits one of the enemies. So I believe we commented this out, so I'm going to do Command F // to find our comments. And I'm just going to keep pressing enter until I find the right one. This is where our objects touch, and to be more specific here, I will say when projectiles touch enemy. So this is where we remove both from the screen. So the deal is, this is where we actually remove our enemy. But inside of this conditional, what we're going to say is, we're going to add an if statement that says, if the enemy's radius is greater than a certain size, then we want to subtract a value from that radius instead of removing it altogether. But once it's beneath a certain size, that is when we're going to remove it from our screen and take it out of the game. So the conditional checks for an enemy's radius. We'll say if our enemy radius is greater than 10, then what are we going to do? We're going to take our current enemy's radius and then subtract from it, let's just say 10 to start. So we're going to take 10 pixels from it whenever we hit it. But if it is less than 10 pixels, we'll use this else statement, then we want to remove it from the screen altogether. So save, refresh, hit a large enemy, and you'll see that the enemy just disappears completely. You kind of see a shrinking, but it's not really the shrink that we want. Well, even when we hit an enemy and the enemy radius is greater than 10, we want to make sure that we remove our projectile, because if we are not removing our projectile during this, then we're just going to keep calling enemy radius minus 10 until we call this else statement. So we want to make sure that we basically end this code right here by removing our projectile. So what we can do is we can take set timeout, paste it right beneath where we're subtracting our radius, and we're not going to splice out our enemy here, but we are going to splice out our projectile. So save and refresh now. We hit a larger enemy, and you'll see it shrinks, it gets smaller, and this is going to work, but you'll see we have a really small enemy right here. It just got so small that it might have been a little too hard to hit and actually remove from the game. So something we can do is, in this conditional, we can say if the enemy radius minus 10 is greater than 10, then that is when we want to shrink it. Otherwise, then we want to remove it from the screen. So basically, if we subtract 10 from our radius on hit, and then it is less than 10, meaning it's going to be really small, something like 4, 3, 2, or 1 pixels wide for its radius, then we're just going to remove it off the screen altogether. So this is a little extra check that we can put in there to make sure that things don't get too small or too hard to hit. So now if I hit a big guy, it gets smaller, but it's never going to get to the point where it's too small to hit. And you can play around with that value a little bit depending on how small you want that limit to really be. But this looks good for me right now, so I'm going to keep it. Now, one thing I want to do is, you might have noticed on our game over here, when we hit a large one, that it progressively shrinks. It doesn't actually just boop shrink, it kind of progressively shrinks into its form. So when I look over here, I hit a large one. We need something larger, like this guy. You'll see it doesn't have that smooth motion, that smooth animation. So to get this smooth animation, we're actually going to use an animation library. And this animation library is called GSAP. So GSAP is GreenSock, stands for GreenSock Animation Platform. What that means, I have no idea, but it's kind of the go-to animation platform for interpolating between values. And by interpolating, I just mean transitioning from one value to another and adding and easing, basically easing curves to make it look like a good transition. So in order to make use of GSAP, what we're going to do is type in GSAP Cloudflare, and we are going to click on the very first result. And this is going to give us an external link that we can reference within our project and not have to download anything extra. So if we select the very first result of 3.5.1, we want to copy the script tag right here. We're going to head into index.html, and right above our current script tag, we want to paste that on in there. So hit save, and now that this is above index.js, we can make use of GSAP's library within index.js. So to prove that this works, at the very top, what we can do is console log out GSAP, and then refresh our page, and you'll see we have access to all of these GSAP functions. So by importing GSAP over here, now we have access to the GSAP library within this GSAP variable. So to make your life easy, this is how we're going to use GSAP. We're going to go back to where our projectile touched our enemy, where we're removing it from the screen, and instead of just immediately subtracting 10 from our radius, we're actually going to tween between this radius value. And by tween, I mean interpolate, and by interpolate, I just mean transition to. It's going to add that smooth animation effect. So instead of doing this, what we're going to do is reference our GSAP object and say we want to transition our enemy. What property of our enemy do we want to transition? We'll specify inside of this empty object. Our radius is what we want to transition, and we want to transition it to our current enemy radius minus 10. So if we save this and now refresh, we want to hit a larger enemy, and I might go ahead and make these even a little larger. You're going to see we get that really nice shrinking effect on the large enemies, and it really is that simple using GSAP. All you have to do is specify the value you want to tween to, and then it'll immediately take effect. So I want to make sure that when we hit these that they actually shrink a little more, because right now only the big ones are shrinking, and even when they're like medium sized, we're just removing them from the screen. So what we can do is we can say we only want to remove them if they're less than 5 pixels wide. So now if we save and refresh, they're going to get a little smaller, and then finally we can remove them from the screen. They're still hittable, but they shrink, and they shrink to a size where we can completely remove them. So that's a little more fun. We add that nice animation effect, and that's really all it takes with GSAP. So looking at our to-dos, we now shrunk the enemies on hit. Now we need to create the particle explosion that we see right here, and this really adds a nice effect, a burst effect of the enemies exploding into a million pieces. So to add this effect, we basically need to create all these particles independent from one another whenever our projectile hits an enemy. So this code is going to go right inside of this if statement, but first we need to make the particles. We need to make the blueprint, which have those individual properties so that they all go in different directions. So to create the blueprint, we need to create a class. We can just go ahead and copy our enemy class, and right beneath it, we will create a particle class. So our particle class has an X, Y, radius, color, and a velocity. So whenever we hit, remember, which we can get to with // whenever a projectile touches an enemy, we want to create a number of particles and then render them on the screen. So to create a number of particles whenever a projectile touches an enemy, we're going to use a for loop. And if we specify here our array length, if we specify a length of something like 8, well then we're going to create 8 particles each time one of our projectiles hits an enemy. So here we can say a projectile's array should push in a new particle. And our particle arguments were x, so our x is going to be exactly where these two touched. We can just specify that this is going to be our projectile's x. So if our projectile touches this guy right here, it's just going to spawn the explosion right here for each particle. Same thing for our projectile y. Our radius, I believe, is next. We can just scroll up, see radius, color, velocity. Command Z to get back to where we were. So now we have a radius. Let's just go ahead and say our radius should be 3. And then our color is going to be the color of the enemy we actually hit. So we can select our enemy color, put it right here. And then we need a velocity. So our velocity is an object that has an x property and a y property. For x, we're going to specify that this is completely random. And to completely randomize our x velocity, it needs to be either negative or positive. So we can't just use math.random, because math.random is always going to be positive, any number 0 to 1. To make this a completely random value that can also be negative, all we have to do is subtract 0.5. Because if we get a random value of 0, subtract 0.5 from it, now we have negative 0.5. But if we get the max value of 1, subtract 0.5 from it, now we have 0.5. So this is basically math.random, but the values that we can actually get are negative 0.5 to 0.5. So that's what we're going to do for x, and we're going to do the same thing for y. Just math.random minus 0.5 to get a completely random value, negative or positive. And now we're pushing all these particles actually into a projectile's array. I'm getting a little confused here. This needs to go inside of a particles array, not a projectiles array. And this particles array we actually haven't created, and we haven't rendered anything on the screen within our animate loop. So exactly where we have our arrays up here, I'm going to copy and paste and then specify that we want to create a particles array. And now that we have this array and we're pushing particles inside of it right here, we need to make sure that we're rendering them on the screen. So remember, to render anything on the screen, you need to loop through it. So what we're going to do is specify our particles for each particle within this particle array. We want to call that particles update function, which in return is just going to call this right here. So save, refresh, let's watch what happens. We hit an enemy, and now we have 8 particles going in different directions. And they just keep on going. They don't actually fade out or disappear over time. So to get these to fade out over time, we're actually going to add an additional property for our particles. And this property is going to be our particles alpha value. Now we don't need to pass in an argument for this because to start, our particles alpha value is always going to be equal to 1. And this means it's always going to be completely opaque. It's not going to be transparent as all. But as time goes on for this particle, we're going to subtract an alpha value from it, which is going to make it fade out over time. So to affect the actual look of one of our particles here, we have to edit our draw function. And when using Canvas to edit opacity values such as alpha, well, it's a little tricky. So what we need to call is right before we begin our path, we call c.save, which kind of puts us inside of this state where we can call a global canvas function, but it's only going to affect the code right here. And then if we call at the very end, c.restore, well, that kind of finishes off the statement of only call this global code right between save and restore. So the code we want to call in between save and restore is going to be c.global alpha, and if we set this equal to something like 0.5 to start, just a static value, we should see the particles a little more faded out as we create them by hitting an enemy. We don't really see much just yet. We'll go ahead and change this to 0.1 to really make sure that they're faded, make sure that this is actually working in the first place, and you'll see that it definitely is. Those are more faded than they were before, but we want to make sure that this fade effect transitions over time. So what we can do is, for each frame within our animation loop, we can subtract a certain value from this.alpha. So inside of update, we're going to take this.alpha and subtract from itself 0.01, and that should be pretty good to get us to 0 over time. But we need to make sure if we're subtracting alpha here and declaring it up here that we're actually using it within our draw code. So instead of 0.1, we're going to use this.alpha. So on creation, it's going to be equal to 1, and then over time, it's slowly going to fade out. So if we save and refresh, hit an enemy, you'll see they begin fading out, but then they reappear. So the reason they reappear is because eventually alpha is going to be equal to something less than 0. And if you plug in a value that's less than 0 into global alpha, well, they just reappear. Not what we want. Instead, as the alpha value reaches 0, we want to remove these particles from the screen altogether. So to remove particles from the screen, we'll go to our animate loop, where we are looping through our particles, and we will add an if statement inside of here that says, if one of the particles, alpha value, is less than or equal to 0, then we want to remove this particle from the screen. So remember, to remove a particle from the screen, we select the original array particles, use splice, specify what index we want, which we can get with for each's second argument. So index, we're going to put it here in our splice, and then specify we only want to remove one object from the specific index, so we put in a 1. And now we will take out a particle as its alpha value goes to 0. We also want to add an else statement that calls particle update. So otherwise we're just going to update the particle and keep calling code. And now, when we hit an enemy, eventually our particles fade out and they are removed completely and they don't show again. Now these particles look a little different than what we have over here. The particles over here look a lot more realistic, and the reason is the particles are different radii and they have different velocities associated with them to really make them unique, random, and something you'd actually see within something like a firework. So where we are creating all of our particles, which is going to be right here, and I'll comment this out that says create explosions. Just make sure that we have clean code. We want to make sure that we're randomizing more of these values. So instead of having a set radius of 3, I want to make sure that this is randomized so we get small particles and then large particles for this explosion, create a more realistic effect. So instead of 3, I'll add in math.random, any value 0 to 1, and multiply it by 2. So any value 0 to 2 instead. So we save, refresh, and hit an enemy. Already looking a lot better. Now what we can do is, based on the enemy's radii, we can go ahead and set how many particles we actually want to spawn. So instead of doing a set value of 8, we can actually grab our enemy's radius, multiply it by 2 just so we get an even bigger explosion. And now our particle amount is going to be dependent on how big the particle is. So the bigger guys are going to have more particles associated with them. I want to add a little more power on these explosions because they're kind of weak right now and not too random. So to add power onto this, where we are generating our velocities for x and y, what I want to do is wrap these in parentheses so we make sure that we always get a negative or a positive value. And then I want to multiply this value by some sort of power. What is that power? Well, I want this to be 8 times the speed and maybe some of them a little less. So if I want a random value here, all I would do is multiply 8 by math.random. And now we're going to get a good powerful explosion, at least for the x velocity. So I want to do the same thing for our y to make sure that we have power in the y direction as well. And on save and refresh, we should get something that looks a lot better, a lot more powerful, which we do. So that makes a big effect, and it might be even a little too powerful. So if it's too powerful for you, you can just go ahead and decrease this 8 value right here to something like 6. And just do whatever your taste likes. So at 6, that looks pretty good to me. I think I'm going to keep that. But I want these to slow down over time. So for each particle, we need to make sure we're adding friction onto its velocities. So we'll go ahead and scroll up to our particle class, and where we are updating the particle, which is going to be right here, we also want to make sure that for each frame we're updating the particle's x and y velocity. So basically shrinking those velocities over time is going to create the effect of deceleration, make it look like they're slowing down. So right above our class, I'm going to create a const called friction, set it equal to 0.99, and this is going to make sure that things don't slow down too quickly. Basically, the closer this value is to 1, the slower the things actually slow down. So now that we have friction, we'll go into update, and right before we update our x and y values, we're also going to update our x velocity and say our x velocity should be equal to itself times friction. We want to do the same exact thing for our y velocity. So we're basically just shrinking the x and y velocities over time by multiplying velocity.x by itself times friction. So on save and refresh, we hit an enemy, and you'll see the particles now have a pretty cool slow effect added to them. And if this isn't noticeable enough for you, what you can do is go ahead and decrease this friction value. It doesn't need to be by a lot, but you should start seeing the effect the more you decrease this. You see things get slow really quickly with that. I kind of liked it a lot better with 0.98, maybe 0.99, go back to that. Yeah, I think I'm going to keep it at 0.99 just so these go really far. That's kind of what I like. So hit an enemy, and that's looking like a really good effect. So looking at our to-do list, we now created a particle explosion on hit. What do we have left? Well, we don't really have a scoreboard added to this. So that is going to be the very next thing. You'll see on our reference piece, we have a score on the top left-hand corner. We need to create this and make sure that when we hit enemies, we're adding a score onto this. So in order to get a score up here, I would never really recommend drawing text on top of a canvas because typically it gets really pixelated. It's not very anti-aliased, and it just doesn't look good. So instead, I recommend creating this text within HTML and then updating the HTML with JavaScript. So watch how I do this. If I want to go ahead and create text that's in the top left-hand corner, all I'm going to do is create a div, and inside of this, I'm going to create a span for just our score label, and then I want to create another span next to it to make sure that score label is separated from our actual score that we'll be adding onto, and I'm going to set this equal to 0 to start. So if I save and refresh, don't see anything just yet, but if you don't see anything, you can always head inside of your Elements tab right here, make sure that we have enough space to see everything, and we're just going to look for this div, find out where it is. So it looks like it's actually beneath our canvas, and there it is. So to make sure it's above our canvas, all we have to do is simply select this div and then paste it above our canvas element. So now on save and refresh, we scroll up and there's our score. Now we want this score to be overlaid on top of our actual canvas game. Right now it's inside of our layout, which means it's pushing the canvas down. So to get something overlaid on top of something, you want to use a CSS class of position fixed. And to use this class, what we could do is just select the div and then style it up here within our style tags, but I really don't like writing CSS this way. There's a lot easier way to do this using a library called Tailwind CSS. So this is a utility framework for creating CSS designs very quickly. You can kind of see how it works over here. Basically, each class gets one style associated with it, and it makes it so you don't have to think of any class names. All the class names are within this framework. You just add them in, and it affects your styling as needed. So I really like using Tailwind CSS for my styling purposes. So what I want you to do is go to tailwindcss.com, and we're going to search the docs for CDN. And this is basically just a library link that we're going to paste into our project so we can make use of the library. So once you're here, there's going to be a link when you scroll down just a little bit. We're going to go ahead and copy this. And right above our style tag, we'll just paste this. Make sure that you actually copy the whole thing, unlike me. And now when we save, we're going to be able to make use of Tailwind CSS classes. So if you too want to see what classes you can use, just scroll on the left-hand sidebar, click something that kind of refers to what style you want, such as flex, and then you're going to see what classes you can use to start altering the things on your screen. So I'm going to guide you through this. In index.html, let's go ahead and resize everything. We need to make sure that this div has a position fixed. So Tailwind CSS has a class called fixed that goes ahead and just makes this div fixed. We save and refresh. Well, now it's fixed. It's overlaid on top of our canvas element. Issue is, it's all black. So in order to make the score white and actually contrast from the background, we can go ahead and add another class called text white. Now on refresh, our text is white. Now for styling purposes, typically you want the score not to be too big on the screen when you're actually playing the game. So we're going to make this text a little smaller by adding a class of text SM, text small, just really easy stuff from Tailwind. That looks a lot better, and now we need a little bit of breathing room from the left and top hand side of our game. So to give it breathing room, we use margin left ML-2. That's going to give us ample amount of spacing on the left. Let's add a little bit of spacing to the top. MT-1. And now our score label is in place, but one more thing. I just want to add a little bit of spacing here between the colon and the 0. So all I have to do is right after a colon, press space, refresh. There we go. Our score label is in perfect place. Now we just need to make sure it's updated whenever we hit an enemy. One more thing before we get there. You'll notice if I begin clicking around and shooting that the score label actually lights up and becomes selected. We don't really want that at all. So this is happening because it has a user select class associated with it. So for instance, I actually forget what this class is within Tailwind CSS. All I have to do is go to the docs and then type in user select the first option, and now I know exactly what class to use. So I'm going to do select none because I want to make sure the user cannot select the score. Just add it on to our div. And then refresh, and now when I click around, it's not selected. We don't get that weird distracting effect. So let's go ahead and update our score now. To update our score, we're going to want to make sure that we can select this right here, everything in between these two spans. So what I'm going to do is go ahead and give this an ID of score L, stands for score element. Copy this, make sure you save the HTML file, and then index.js. Whenever I select an element from my HTML, I like going to the very top of my page, similar to like what I did with Canvas right here. I'm going to go ahead and beneath our Canvas code, I'm going to create a const called scoreL, select our document because remember our document is everything within this HTML tag. Well, what tag do I want to select? This span right here. If I refresh and look at that span again, has an ID of scoreL. So we'll go ahead and say this is equal to our document, query selector, and we want to select this by its ID. So we'll add in hashtag, #, hashtag, and then we want to select it by its scoreL ID right here. So we save, console log this out, and refresh just to make sure it's working. Now we have our element, 0. So now we can begin editing this as we begin to hit enemies on our screen. So same deal to find out where we need to go. Command F, // enter. Enter when projectiles touch enemy. This is where we want to basically increase our score. So whenever we hit an enemy, how much should we increase our score by? Probably something like 100. But in order to increase a score, we need some sort of let, some sort of variable we can alter and actually add values to. So to create this let outside of our animate loop, right beneath animation ID, I'm going to add another let called score. This is going to be equal to 0 to start. And then back where we actually hit our enemy and increase our score, this score variable is going to be equal to itself plus 100. So if we save this and refresh, start hitting enemies, you might expect the score to increase, but it's not. What's really happening is this score variable is increasing behind the scene. So if I console log this out, refresh, when I hit an enemy, you're going to see the score right here increase to 100. If I hit another enemy twice, you're going to see it keeps increasing. We need to make sure that this increasing score is actually set to that element we just pulled in through our HTML. So as we create our score, we want to set our scoreL's inner HTML. So everything inside of our span tag, which is just 0 right here, we want to set this equal to our actual score value. And when we do this and refresh, hit an enemy, you'll see our score label starts to increase on the top left-hand side. Now let's say we want to add a different value for when an enemy shrinks compared to when we remove it off the screen. Well, this is going to be quite simple. So let's go ahead and take this increase our score code, cut it out, make sure you copy that, and then where we are actually shrinking our enemies, we'll go ahead and edit our score differently. So if we hit our enemy and it shrinks, it's pretty big, we start shrinking it, we're going to increase our score by 100. But if we remove it from our scene altogether, right here, move from scene altogether, then we want to go ahead and increase our score by 250. Give the user a little bit of a bonus for completely removing the enemy away. So save and refresh, and we should see two different score values here. So hit a big one, 100, remove it from the scene, 250. And this works exactly as expected. If we end up losing the game, well, everything pauses, but we pretty much just took care of increasing our score label and getting it on the screen. So let's look at our checklist. We added our score, but now it really just comes down to adding a good UI for our game. So let's go ahead and look at the reference. We have this modal on top of everything that allows you to start the game, and then you'll see once the game actually ends, once the enemy hits me, we're going to get an end game modal that shows our current score, and then we can restart as needed. So basically, we're going to take care of these three all together. Let's go ahead and create this start game modal. So we're going to learn a little bit of HTML and CSS to go along with this. So within index.html, to create this modal, like we see right here, let's go ahead and analyze it. Well, this is going to be separate from our label up here. And as a result, we want to create a separate div. This div is going to have a background of white, you might think, but really what we need is a container div to basically hold this white background div in place. A little confusing, but bear with me and we'll get there. So this div is going to have a div inside of it with a class of background white, so this is going to be this guy. Now inside of this white div, what do we have? Well, we have a large 0, so whenever you want to use large text, you can add an h1 class. H1 is basically the largest text you can get, so we're going to go ahead and use this and say our score is going to go right here, so 0. Beneath it we have a points label. So typically for labels, if they're not associated with a form, I just use a p tag, a paragraph tag. I'll put points in here. And then beneath it, we have a button. Now button element, I believe it is inline by default, which means its layout is going to be a little different from that of an h1, p tag, or div. So what I'm going to do is actually wrap button inside of a div. And this button has the text start game. So if we save this and refresh over here, now we have basically our white modal, but in a lot worse looking form than what we want. So same deal, this is just being placed above our canvas. It's currently in the layout. So to take it out of the layout, we take our main div, our root div right here, and add a class of fixed, and this is going to take it out of the layout. So now when we save, it's out of the layout, it's overlaid on top of everything. But we want to make sure that this is completely centered. So to completely center this, let's go ahead and inspect what we have right here. So right click, inspect, you can click this little guy right here and really get granular with what you want to select. We have our fixed div. So what needs to happen is this fixed div right here needs to expand the entire width and height of the browser. And to do this with CSS, what we're going to do is set the values of top, left, right, and bottom all equal to 0, and it's just going to make the whole thing take up the entire screen. So to do this with Tailwind, we can add a class of inset0, and it's automatically going to add those exact styles we need. So we save, refresh, now we have this inset0 class, and you'll see it adds top 0, right 0, bottom 0, left. And when I hover over the element, you'll see it takes up the entire screen. So next, let's go ahead and get our modal actually centered. To center this modal, we want to add on a class of flex to this div to put it into flex mode, which allows us to center things really easily. So once this div has a class of flex, we can use flex classes, such as item center, and this is going to center it vertically. So save and refresh. You'll see now it's centered from the top and the bottom, but we also want to make sure it's centered in the middle. So we'll add another class of justify center, which when used with flex, it's going to center it in the center. And now we're starting to get the effect that we have over here, but we're not there just yet. We want to make sure that this is a specific width. Now to make sure background white, this div right here, is a specific width, we can give it a class of max width. I'm just going to say that this should be a medium-sized max width. Save and refresh, nothing's going to happen. But if we add on a width of full, meaning it's going to extend the full width of its max width, meaning it can extend past this value right here, you're going to see now it has a specific width associated with it. Hopefully that makes sense. So now that we have this max width, we need to make sure that we have breathing room here for our values. So this is pretty easy. All we need to do is add a padding for all the edges of our screen, which we can do with Tailwind. Just add a p dash. Let's start off with 6. Save and refresh. Looks good to me. And now we want to make sure that this looks like we have over here. So we're also going to be learning a little bit about design. So for our 0, we want to make sure that this is the #1 thing that stands out. This is going to be our main focus because this is what the user cares about. To make this stand out, we want to make sure that it is the largest and boldest thing on our screen, but not extremely large. So our h1 is going to have a class of text dash 4 times extra large, make it pretty big. Refresh, that's looking good. I also want to make sure that this is bold, so I'll add a Tailwind class of font bold. And yeah, that's going to be the #1 thing that stands out. But you'll see points and start game both have the same font, which means they both have the same amount of attention as we look on our UI. Since points is a label, we want to make sure that it has the least amount of attention to everything else. It's secondary to our score and it's secondary to actually starting the game. So to decrease the amount of attention we give our points label, we'll add a class onto our points tag. And what we can do is, one, we can make it smaller. So add text-sm, that's a good way to start. So definitely a little less attention. We can also start graying it out, start fading the black background, give it less contrast. So we'll add a text gray, a 700, de-emphasize this quite a bit. That's already looking a lot better. And I think that's really all we need to do. So now we know that points stands out from our score and also our start game button. Let's go ahead and get all of this centered. So within background white, we'll add a text center class. refresh. Now everything is centered. And let's start creating our button right here. So to create this button, within our button element, we'll add a class of background blue 500. This is just going to be a mid-tone blue from Tailwind. Looking good. We want to make this text white. Make sure that it has good amount of contrast, enough to actually see something that looks good. Maybe not a lot of contrast, but you know, it still looks good. We want to make sure that this extends the full width of our container. So we'll go ahead and add a width full class. And now it's extending the full width. Let's go ahead and give this some padding. Our PY padding for top and bottom is going to be something pretty small, so PY3. I think that looks pretty good. And we want to make sure that this is fully rounded to give it a playful effect. Typically, square borders mean it's more serious. That's at least the effect that it gives off. We want to make sure this is playful, so we're going to round it with rounded full. Save and refresh, and now that's looking very similar to what we have over here. Now a few edits, I would just get points closer to 0. And if we inspect 0 right here, you'll see there's no margin or padding actually pushing points down. What's happening here is 0 actually has a certain line height associated with it that's pushing points down instead. So to give this no line height at all, we'll use the class of letting none within h1. So save and refresh, and now we get rid of that extra spacing. But now points is quite close to start game. So within our points tag, we'll add MB4 for margin bottom 4, just an ample amount of margin bottom. And I think that's pretty good. I might actually just de-emphasize start game a little bit. So what I'll do is make this text SM, smaller text. And that looks pretty good to me. Pretty close to what we have over here. Maybe not perfect, but good enough. We're matching the same effect. So we created the UI, but you'll notice in the background that our game is actually starting before we click the start game button. So in index.js, remember, whenever we load this file, we're calling animate and we're calling spawn enemies, which starts our game. We don't want that to happen anymore, so we're going to go ahead and cut this out, make sure it's copied to your clipboard, and then we want this to activate whenever we click on start game. So to add an event listener to start game, what we want to do is basically emulate what we have right here, but instead of attaching this onto our window object, which is hidden, remember, we want to attach this onto our start game button. So we need to go in our index.html and give our button an ID, start game element. And actually, to be a little more specific, I'm going to call the start game button BTN. And up at the very top, where we are basically creating our score L into our JavaScript, we want to do the same thing for our start game button. So start game button is equal to our document. We want to select an element with the ID of start game button. Game button. So now that we have access to this element, we can add on an event listener. So we're going to scroll down to the very bottom of our page where we're already adding on an event listener to window. But instead of adding this on a window, we'll select start game button and say add an event listener onto this. It's going to be a click event. So whenever we click this, code should fire. And to test this, we'll console log out go, refresh, and then click start game. And you'll see go is actually firing. So instead of firing go, whenever we click start game, we want to call animate and spawn enemies. And on save, refresh, start game, you'll see our game begins to go in the background, but we need to remove this modal altogether. We need to remove this interface right here when we click our button. So same deal, we need to select the element within our HTML. The element within our HTML is this entire thing. So we want to add an ID of modal L to the entire element that contains everything right here. When we do that, we head into index.js, scroll to the top of our file. We can copy this line of code right here. Say that we want to create not a constant to start game button, but what is our ID called? Modal L. We'll replace this with that. And then we want to make sure we're selecting the element with the ID of modal L. So now we can select this element, which is HTML, within our JavaScript. And whenever we click on start game button, we're going to animate and spawn enemies, start our game basically. But we're also going to take our modal L, select all of the styles associated with it, style, and then change its display style equal to none. So when we do this, it's going to hide altogether when we click on start game. So refresh, click the button, it's gone, and now we are starting our game. Now something a little weird there, if we refresh, you'll see that the whole background is white to start because we're only drawing on our background when the game actually starts. So to make sure that our background is black here as well, within our style tag in index.html, we can set our body equal to a background of black. So now on save and refresh, everything looks as expected. We start the game, we hide the modal, we start firing at things, and eventually the game is going to end when one of them touches us, and the game ends. Well, now we need to show that same exact modal with our updated score. But first, let's go ahead and check our to-do list. We actually started with our start game button, so we'll go ahead and swap the order of this. We'll check this off. And now we need to add the game over UI. So we're just going to use the same modal that we had. Basically, if the modal pops up, you know the game is over, and you're going to see your exact score. So when an enemy hits us, we don't want to change the style of our modal L to display none. We want to change it back to its original display, which if we look in index.html, our modal L has a display of flex because we're adding a flex class right here. So that's what we need to set it equal to whenever we end our game. So all we have to do is copy this line of code, find out where we end our game, and it's going to be right here, canceling the animation frame. And we're going to paste in that line and set our display equal to flex instead of none. So now, refresh, start the game, just wait for an enemy to hit you. Actually going to hit 1 just to get some points on there. And now our modal reappears. If we click start game, well, we need to add restart functionality. But first thing first, when an enemy hits us, we need to make sure that we update that score on the modal. Because if you see, if I hit an enemy, and it hits us, well, our score isn't actually updated right here. So that's the first thing we need to do. We need to make sure that we select this element and then set it equal to our score whenever we end the game. So this element is going to be this 0 right here. We want to add an ID of big score L because it's going to be different from score L, which is this guy right here. We want to make sure that we're also editing the big 0 instead. So now that we gave it an ID, we'll head into index.js. Same deal. Just scroll to the top of your page, select the element from HTML. This is going to be called big score L. Make sure you're selecting the right one by selecting the big score L ID. And now, when we end the game, / end game, right where we reappear this thing with display of flex, we're going to edit our big score L's inner HTML and set it equal to our actual score. So now on save, refresh, start game. We hit an enemy, 100 points. 100 points shows right here. So we can go ahead and check off game over UI, but now we need to actually restart our game and make sure the scores update correspondingly. So to restart our game, you might think that if we call this code again, where we click on start game button, that everything might be just peachy. So let's hit it. We start the game. Our display is equal to none. We call animate and spawn enemies, but nothing is happening. All of our previous enemies still show on the screen. You'll see our particles. Our score is still there. We need to make sure that we reset all of this whenever we click that button. So wherever we are initializing values, we need to make sure that we put those inside of an init function. Call that init function on start, and then also call that init function on start game button click, and it's going to reset everything when we do that. So we're just going to scroll up to where we initialize all of our arrays that contain all of our projectiles, enemies, and particles. And what we're going to do is we're going to create a function right beneath them called init. And in here is where we're actually going to set things such as our player, our projectiles, enemies, and particles. So if we want to set these, but make sure that they're still accessible in other functions, we want to change const to let, like so. And then we just want to go ahead and copy all 4 lines right here, paste it within init, and then we can't use let twice, so we're going to go ahead and get rid of let right here, assign these equal to the same values we assigned them to up here, and now whenever we call init, we're going to reset everything, and we're going to make sure our canvas is cleared when we click restart. Well, the first thing we need to do is actually call init, so whenever we click and restart our game right here, we want to reset everything with init. So save, refresh, start the game, hit an enemy, get that score up, and then let an enemy hit you, hit start game again. Well, everything clears, and now the game is actually restarted because we added that init function. So you might notice that our score is 1800 right now, and when we click start game, it stays at 1800. We want to make sure that we reset this every time we reset our game. So within init, we want to find that init function, which Command F parentheses allows us to find it really quickly. We want to set our score equal to 0 each time we call init. Then on save and refresh, start the game. Let's watch what happens. We start increasing our score. It's going to be 250. We get hit. Start the game again. Well, score did not update up here because although we're setting our score value right here, remember we also need to update our score within the HTML because otherwise we're just setting this on the back end, basically like hidden within JavaScript. So to set the actual labels, we need to select our score L, set its inner HTML equal to score, and then remember we need to do the same thing for our big score. So we'll select our big score L, refresh, start the game, rack up some points, allow ourselves to get hit, 350, and now when we click start game, we are reset at 0. We get a different point value, get hit, and now our score is showing as needed. So now if we exit out of our console, full screen this, refresh the page, and click start game, we now have a fully functional game with a start screen, explosions, particles firing everywhere, and it's still easy but not too hard, where this can actually be something that people enjoy playing. You always want to find the right balance of making something easy and not too hard. So eventually, when an enemy hits me, if I let it, because I'm pretty too good for this game, we're going to get our points, we can restart as needed, and now we have a fully functional Canvas game completely from scratch, coded by you. Everyone, thank you so much for watching this video. If you enjoyed this and would like to take your game development skills to the next level, be sure to check out my full game development course linked in the description of this video. I basically put this tutorial on steroids, showing you how to add over 20 plus features such as player movement, power-ups, and different kinds of enemies. There's really so much to learn that I guarantee you'll walk away satisfied knowing that you know all of the basics that you need to create any kind of game. Otherwise, be sure to support the channel with a subscribe and a like, and I'll see you in the next one. Peace.